Okay, picture this. You step into the Coliseum. The gates are closing right behind you, the timer's ticking down, and it's just you against the paper. Welcome to the 9709 arena. Listen, if you're sitting the Cambridge mathematics exams, you already know the stakes. You know that the difference between just barely surviving with a B and actually emerging victorious with that A star, well, it almost always comes down to one massive boss battle. And that is probability and statistics too. It's the paper that makes or breaks grades. Today, in this explainer, we aren't just going to sit here and stare at formulas on a whiteboard. No way. We're going to be looking at real, hardcore survival tactics, pulled straight from the actual principal examiner reports. We are getting into the mind of the people grading your papers. So take a deep breath, let's dive right in.
So I have to ask, are you truly ready? Let's take a look at what usually happens when the pressure is on in the heat of battle. I want to introduce you to two specific students who are currently fighting for their absolute lives in a really complex sampling and estimation question. Let's look at the left side first. Here we have Alex. Now, Alex is smart. Alex has memorized literally every single textbook definition. But look at their exam paper. It is just bleeding red ink. Why? Because Alex overloads the page with raw mathematical facts, but completely ignores the actual context of the data. They're just throwing numbers at a wall hoping something sticks. Now on the right side, we have Sam. Sam is doing what most of us do, panicking about that ticking clock. Sam rushes through the working, completely skips the command word requirements, and just slaps down a final numerical answer at the bottom of the page. And guess what? Both of these students lose massive marks. Because here is the secret. Cambridge examiners aren't just testing if you can blindly use a calculator. They're testing your ability to interpret complex texts, structure completely logical reasoning, and apply those abstract concepts to entirely unfamiliar real-world contexts. And that exact challenge is what we are going to conquer together today.
So here is our battle plan for today's explainer. Section 1, your statistical weapons. Section 2, the procedural battle framework. Section 3, surviving examiner traps. And finally, Section 4, the ultimate victory system. Let's get to it. Starting off with Section 1, your statistical weapons and the core principles you need to master.
Okay, to completely defeat this paper, you need deep conceptual understanding. And that starts with avoiding the single most fundamental trap in the entire arena, which is confusing the sample with the population. Look, a population is the entire group you actually want to draw conclusions about. It's defined by true parameters, right? Like the true mean, which we denote with the Greek letter mu, and the true variance, which is sigma squared. But here is the reality of the exam arena. You are almost never going to have the data for the whole population. Instead, you are given a sample, just a small slice of the pie. And from that sample, you calculate statistics, like your sample mean, x bar, and your sample variance. The absolutely crucial point here, the thing you cannot forget, is that you are using this tiny sample to estimate the giant population. So if a question asks you to find an unbiased estimate of the population variance, you can't just calculate the variance of your little sample and stop there. You'll lose the marks. You must apply Bessel's correction. You have to multiply your sample variance by n over n minus 1. If you confuse those sample dynamics with population dynamics, your entire analytical framework just collapses from step 1.
Now, to handle all these samples, you are going to need some heavy artillery. And I mean heavy. Enter the central limit theorem. Look at the definitions we're showing here. The expected value of the sample mean, E of x bar, is perfectly equal to the population mean, mu. That makes sense, right? But look at the variance. The variance of the sample mean, var of x bar, is actually the population variance, sigma squared, divided by n, which is your sample size. Why does this matter so much? Because of the central limit theorem. This is literally your ultimate weapon. This theorem states that if your sample size n is large enough, and Cambridge typically defines that as being over 30, the distribution of your sample means will be approximately normal. And here's the kicker. That happens even if the underlying population is completely skewed, or uniform, or totally weird. This magic rule allows you to construct confidence intervals and run hypothesis tests on almost any data set they throw at you. But, and this is a massive but, the syllabus strictly prioritizes analytical depth. You must explicitly write down in your exam answer, and I quote, assuming n is large, by the central limit theorem, x bar is approximately normally distributed. If you just silently use the formulas without physically writing down the name of the theorem, the examiner is going to dock your marks for lacking conceptual understanding. You have to show them that you know why you are doing the math.
Before we continue and forge your actual step-by-step exam strategy, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, the procedural battle framework. This is where we talk about the standardized sequence.
Behold the mathematics success blueprint. This right here is the standardized 5-step sequence that the principal examiner reports literally beg students to use year after year. Step 1. Identify the key elements. Before you write a single number, ask yourself, is this a normal distribution, is it a binomial, or is it an unknown population where I need to invoke the central limit theorem? Step 2. Apply the relevant principles. Select the absolute correct formula from your mental arsenal. Step 3. Execute the analysis. This means showing clear, line-by-line, step-by-step working. No skipping steps in your head. Step 4. Verify your results. Honestly, just use some common sense here. Does a confidence interval of negative numbers make sense if you're calculating the physical weight of a product? Definitely not. And finally, Step 5. Present your answer in the correct format. Use proper mathematical headings, correct terminology, and the right significant figures.
Let's look a little closer at how you actually do this tactically on the paper. First, deconstruct the question's command words. This is so important. If the command word is calculate, you just need to show the numbers and the final result. But if the command word is show that, oh boy. Every single algebraic step must be visibly written down on that page, or you get nothing. Next, extract the relevant data parameters. Don't leave the numbers hidden in that big block of text. Pull them out. Write down n equals 50, sigma squared equals 12, right at the airy top of your working area so you don't lose them. Then, select your analytical framework. Are you building a 95% confidence interval? Cool. Write down the core formula first. X bar plus or minus z multiplied by the square root of variance over n. Finally, execute all of this with incredibly clear mathematical notation. Please do not just write numbers floating randomly in space. Use your equal signs. Use your implementation arrows. This kind of logical, step-by-step structure is exactly what separates the elite, top-tier candidates from everyone else.
Let's look at an actual transformation to see this in practice. Remember our struggling students, Alex and Sam? Their flawed methodology is in the first column. They either forget to divide their variance by n, or they skip the real-world context entirely, just giving a floating number. But look at the second column. A winning methodology turns those red examiner marks into beautiful green check marks by actually applying a structured framework, like the Peel structure: point, evidence, explanation, link. First, you state the parameters clearly. Then write the correct formula, explicitly showing the variance as sigma squared over n. Next, and we talked about this, write the actual words, using the central limit theorem as n equals 50 is large. Finally, you have to use comparative connectives to link it back and answer the actual question. You write a sentence like, therefore the 95% confidence interval suggests the manufacturer's claim is valid. Boom! That right there is a complete masterclass in scoring every single available mark on a 9709 paper.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's get into Section 3, Surviving Examiner Traps. We need to evaluate the common pitfalls.
I want you to read this exact quote pulled directly from the Principal Examiner Report. Read it carefully. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. Guys, this is your secret shield in the arena, the method mark strategy. In Cambridge exams, these M marks are awarded simply for applying a correct mathematical method, even if your subsequent arithmetic is totally flawed. Let's say you are calculating a standardized z-score. If you just write down the basic setup, z equals x bar minus mu, all divided by the standard error, you instantly earn the method mark, just for the setup. If you get nervous and punch the completely wrong numbers into your calculator a second later, you only lose the final accuracy mark. You do not lose the whole question. So the golden rule is never ever do complex probability and statistics calculations entirely in your head or solely on your calculator screen. Put your sword on the page. Show you're working.
Let's break down the top 3 fatal mistakes that examiners see over and over. Trap number 1, using the wrong approach for the context. This usually happens when a student blindly applies the normal distribution formula to a tiny sample, like, say, a sample of just 12 items, when the problem explicitly stated that the population is skewed. You absolutely cannot use the central limit theorem there, but people try it anyway and lose everything. Trap number 2, forgetting your format and presentation conventions. This could mean failing to use proper headings or, and this is a huge one, rounding your numbers prematurely in the middle of a calculation. If you round too early, that error cascades and results in a massively incorrect final confidence interval. And trap number 3, leaving your final answers completely divorced from the specific context. If the exam question is asking you about the lifespan of a specific brand of battery, your final conclusion cannot simply be a generic reject H0. That means nothing. It must be something like, there is sufficient evidence to suggest the mean lifespan of the batteries has decreased. Context is everything.
Okay, I want to test your reflexes right now. Look at the data scenario on your screen. You've got 60 seconds. A researcher takes a sample of 15 commute times from a highly skewed distribution and then applies a normal z-value of 1.645. Can you spot the critical flaw in their methodology? Look really closely at the sample size. Look at the distribution shape. Do you see it? The flaw is that n is only 15. You cannot apply the central limit theorem here to justify using that normal distribution formula. Remember the rule? The sample size absolutely must be large, generally greater than 30, to use that specific analytical framework on skewed data. If you spotted that trap, you are already thinking exactly like an A-star gladiator.
And finally, Section 4, the ultimate victory system and achieving higher-order mastery. To completely dominate this paper and achieve higher-order mastery, you have to hit these 4 specific pillars flawlessly. First, you must calculate unbiased estimates with absolute precision. Like we talked about earlier, always remember to distinguish between a simple sample variance and an actual unbiased estimate of the population variance. Second, you have to construct and interpret your confidence intervals. Don't just find the mathematical interval and walk away. Explain what it actually means to a normal human being. It means we are, for instance, 95% confident that the true population parameter lies within this specific range. Third, utilize comparative connectives. When you are comparing 2 sets of data or 2 different statistical approaches, identify the similarities and the differences. Use connecting words like whereas, similarly, or in contrast to weave your mathematical findings into a logical narrative. And fourth, deliver justified recommendations. When the exam explicitly asks you to evaluate an alternative approach, you must support your final conclusion with the hard statistical evidence that you just calculated.
Let's synthesize everything we've learned today into 3 golden rules for your victory system. Rule 1, command word decoding. The exact second you read a new question, I want you to literally circle the command words with your pen. Let those words dictate your required level of depth and working. Rule 2, apply the standardized sequence. Rely on that Peel framework. Point, evidence, explanation, link. Structure your mathematical reasoning completely logically. Write down your definitions. Show every single step of your method to lock in those safety M marks and explicitly state theorems like the central limit theorem by name. Rule 3, context and format verification. Never, ever leave an answer as just a naked number floating at the bottom of the page. Wrap your final answer firmly in the context of the real-world scenario that they gave you and take 2 seconds to double-check that your format, your rounding, and your notation perfectly match standard Cambridge conventions.
The data speaks for itself. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
You've survived the explainer, but the real arena still awaits you. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Remember, master the difference between sample and population, always respect the central limit theorem, and for the love of math, show you're working. I'll see you in the next session.